Good afternoon, welcome back to my channel. In this video I'll be starting from number 4 to number 6, but I'm going to start from number 6 because number 4 and number 5 they are pretty simple. So I'll go to part number 6. So number 6 said she proved that x to the power of 4 plus b to the power of 4 is equals to x plus what? Alpha plus beta is all squared minus 2 alpha beta all squared. Now which is equal to this alpha plus beta all squared minus 2 alpha beta minus 2 alpha square beta square. So now to prove this, now I'm going to start with the simplest thing I know. I'm going to start with that alpha plus beta is equal to all square equal to alpha square plus beta square plus 2 alpha what? Beta. Actually I want to get this. So what am I going to do now? If I add alpha plus beta square minus 2 alpha beta, it will give me alpha square plus what? Beta square. Right? Yes. And moreover, you remember that alpha plus beta all squared is equal to alpha plus beta is power 4, right? Yes. So here now we have this. This is equal to this. So if I square this now, if I square this again, if I have a raised to the power 2 plus b alpha raised to the power 2, alpha raised to the power 2 plus beta raised to the power 2 all squared, I'll have alpha raised to the power 4 plus beta raised to the power 4 plus alpha squared, 2 alpha squared beta squared. So this is what I'm going to get, right? Yes. This is what I am going to get. So if I want to keep this one alone again, I'm going to say that this is alpha square plus beta square all squared minus 2 alpha squared is equals to alpha raised to the power 4 plus beta raised to the power 4. Is that what we got? Yes. Now I want you to see something. Just that I started from the little one I know, I have showed you that this is equal to this and this is it in this line. A alpha plus beta square minus this is equal to this. It's equal to this. Because this one that here that is in this bracket is this. When you expand this, you are going to get all of this. So when you subtract this, you still get this. So I started from where I know, from the simplest one. I proved that this is equal to this and that this is equal to this. I came here again, I showed that this is equal to this, and I obtained that alpha raised to the power 4 plus beta raised to the power 4 is equal to this. And that is the end of the proof. There are still many other ways. This is not the only way to prove it. And going over to number 5. Number 5 says alpha square plus alpha square beta square is equal to alpha beta all square. Now how do we do this? It's simple. We use the law of indices. When they are the same power, you multiply or divide the base. So there's a power here, I just multiply it. I have alpha raised to the power 2 all in bracket multiplied by beta to give me what? Alpha multiplied by alpha beta all raised to the power 2. So number 4, 1 over alpha plus 1 over beta to be equal to alpha plus beta all over alpha beta. Now this one is also simple. The first thing we do is to look for the LCM, take the LCM, and the LCM of these two base of the two unknown is multiplying the two unknowns, two variables together, which is what? Alpha beta. And we have alpha beta squared is still multiple, but the least of them is alpha beta. So we have what? Alpha beta. When this alpha here divide this alpha beta, you have beta. So that's why we have beta here plus the same thing alpha, and it can also be alpha plus beta all over alpha beta. Now if you are proving from this way now, it will give you that alpha plus beta all over alpha beta. This can be equal to alpha all over alpha beta plus beta all over alpha beta. When this divided, have what? 1 over beta plus 1 over alpha. So that is it, and that is the end of the proof. Now in my previous video I gave you something to try out. Actually it's from this number 3. It's from this number 3. I remember the alpha plus beta all raised to the power 2 is equal to alpha plus beta raised to the power 2 minus 4 alpha beta. I told you that when you want to prove this, sorry, this is minus. This is minus. That you should prove this, and when you prove this, that you should not use alpha minus. Like what I did was alpha minus beta is all is equal to 2 is equal to alpha squared plus beta squared minus 2 alpha beta. So now, but I remember that this here, I remember that this in here, okay, that this in here, when I do alpha plus this alpha plus beta here is equal to alpha plus beta all raised to the power 2 minus 2 alpha beta minus 2 alpha beta. Now this is going to give me alpha minus beta all squared. So now alpha minus beta all squared is equal to what? Alpha plus beta all squared minus 4 alpha beta. And I told you not to use this, that you should use alpha plus beta all squared. And that is all I'm going to do now. So I will now say using alpha plus beta all squared to be equal to alpha squared plus beta squared plus alpha 2 alpha beta. So what I'm going to do now is, I'll now say that, okay, since this is equal to this, I would like you to remember that alpha, okay, now that this one here now, if you use this here again, you are going to return back to this. Like if you say that alpha square, okay, if you say that this now is equal to alpha plus beta all square minus 2 alpha beta. Now when you add this plus 2 alpha beta again, you are going to go back to this. But that is not what we want. What we are actually looking for is to obtain this. So we now say that this is what? Alpha squared, alpha minus beta all squared plus 2 alpha beta. So now what we're going to have here is what? Alpha plus beta all squared is equals to alpha minus beta all squared plus 2 alpha beta plus 2 alpha beta. So now this is going to give us alpha minus beta all squared plus 4 alpha beta to be equals to what? Alpha plus beta all squared. So now we add negative of this 4 alpha beta to both sides. So now this is going to give us alpha minus beta all squared is equal to alpha plus beta all squared minus 4 alpha beta. So you can use the two methods to prove it. Thank you for watching. I remember it's Timothy. Do have a nice day. Thank you.